Alright, so biotransformation of butylated hydroxy anisole. Now, butylated hydroxy anisole is normally used as food additive, food preservative to preserve food. But they've seen that this butylated hydroxy anisole can cause reproductive disorders. It is also carcinogenic. What is a carcinogenic substance? Substance that can cause what? Cancer, right? Can cause uncontrolled growth of cells. So, how can the body biotransform this? Remember, on its own, it's not very toxic, right? Because it is a food preservative. So, generally, it's not considered a toxic substance. But studies have recently shown that even as it's preserving your food, when the food is taken in, it can cause cancer and it can cause reproductive disorders. So how is it biotransformed? Because your body is there to protect you. Your body is there, the liver is there to break down toxins in a process called what? Detoxification, right? Good. Now, this butylated hydroxy anisole can undergo phase 2 reaction. And one of the phase 2 reaction it can undergo is what? Glucuronidation. To show glucuronidation, first of all, let's know how to draw the structure of this butylated hydroxy anisole. First, the structure of anisole. You have your benzene ring. Then you have an O-methyl group. Yes. Then we said butylated hydroxy, right? Para-hydroxy. Then butylated, meaning we are adding a butyl group, right? The butyl group is a tertiary butyl group. Para 1, 2, 3, 4. That is how it is. Alright, so this is a butyl group. 1, 2, 3, 4 carbon. But it's tertiary butyl group. Now, this is the structure of your butylated hydroxy anisole. Now, this butylated hydroxy anisole can undergo glucuronidation in the normal way glucuronidation reaction is done. What is always our donor in glucuronidation reaction? UDP glucuronate. And what will be given off? And what's the name of the enzyme? UGT, right? That is UDP glucotransferase, right? Good. Now, if that is the case, remember what we are doing is we are attaching what? Glucuronate, right? Where will the glucuronate attach? Is it here or here? OH, right? So glucuronate can be attached here. We just remove the hydrogen and attach your glucuronate. Is that understood? So at this point, you can have something like this. You can have this. This is my anisole. This is my butylated anisole. And here, instead of OH, I put my what? Glucuronide. Okay, what will be the name? What will be the name of this compound? Butylated hydroxy anisole glucuronide, right? That's it. Please, if you are drawing it, ensure you put this name and the enzyme. They are very important. The second reaction, phase 2 reaction that butylated hydroxy anisole can undergo is sulfation. Now, the sulfation here is just like any other sulfation we've been doing. Now, if we start with our butylated hydroxy anisole, if I want to draw that, what do I draw first? Benzene ring, right? What do I have here? OCH3, right? What do I have here? And what do I have here? Now, if this is undergoing sulfation, what is always our donor in sulfation? PAPS, right? What is PAPS? Phosphoadenosine polysulfate, right? Now, if PAPS is coming in, it will go as what? PAP. Phosphoadenosine phosphate, right? If you say Akamo, it consign you. But what we are interested in is what? The S, right? The sulfur. Now, if we are, what will be the name of the enzyme? Thank you very much. Sulfotransferase. So if sulfotransferase transfers this, where is the entry? Yeah, right? So we'll be having yes, what? O what? SO3. So this is what? Butylated what? Butylated hydroxy anisole sulfate, right? That's it. Now, we've seen that butylated hydroxy anisole can undergo conjugation with what? Glucuronidation, right? Can also undergo conjugation with what? Sulfur, right? Now, another reaction that can take place is O-demethylation. This is not a typical phase 2 reaction because we are not conjugating with something. This is a phase 1 reaction. Now, O-demethylation, let's remember the structure of our butylated hydroxy anisole. Here is what? What do I have here? O what? And here I have my butyl group, right? Now, when they said O-demethylation, meaning we are removing the methyl group on O. Demethylation, removal of methyl group. So O-demethylation, you are removing the methyl group on O. So if you remove the methyl group on O, what you'll be having is something like this, right? But oxygen is supposed to have how many bonds? How many? 2 bonds, right? So we'll complete it with the hydrogen. Sorry? What we just did here was methyl group was leaving. We just removed this methyl group. That's why we call it O-demethylation. The methyl group present on O was removed. So if this is removed, we are left with O. To balance it, we add hydrogen. Do you get that? Forget about the name first. Understand what happened here. We just removed this methyl group, and that was all. Do you get that? Now, this can still undergo further reaction. This can undergo further reaction. If this is oxidized, we can have something like this. So this can be oxidized to this. Oxidation, we are removing this hydrogen to this. Now, oxidation reaction, is it part of phase 1 reaction or phase 2 reaction? Phase 1, right? Now, what we did here, O-demethylation, we remove the methyl group, right? As we remove the methyl group, we expose a new functional group, which is hydroxy group. After that, the next thing is what? You can do what? You can oxidize, which is a typical phase 1 reaction. And this oxidation now introduces double bond here. Do we get that? Now, talking about the name, this is already BHA, right? Butylated hydroxy anisole.